Welcome! Today, we're jumping past the Java 101 stuff. We're going to dive deep into the concepts that really power modern professional applications. We're talking high-performance concurrency, super elegant data processing, and writing code that's robust and safe. So, does this sound familiar? You've got the basics down cold, but you feel like you've hit a plateau. You know there's this whole other level to Java, but you're just not sure how to get there. You're ready to build those really complex, powerful apps, but what's the next step? Well, here's the thing. Making that leap isn't just about learning more syntax. It's a total mindset shift. It's about starting to think like an architect, focusing on design and performance. And those are the skills you absolutely need to build serious, scalable applications.
All right, let's get right into it. First up, we're tackling one of the most powerful and, let's be honest, sometimes tricky features in all of Java, concurrency.
So what exactly is concurrency? At its heart, multi-threading is just your program's ability to do more than one thing at the exact same time. You can think of each thread as its own little independent worker, all chipping away at a bigger job simultaneously. Now, how we manage all these workers has changed a lot. The old way was a total headache. You had to manually create, start, and babysit every single thread. It was incredibly complex and so easy to make mistakes. The modern way? We use something called an executor service. Think of it as a brilliant manager that oversees a whole pool of threads for you. It simplifies everything and makes your code way more efficient.
Okay, but all this efficiency brings up a really important question. What happens when you have all these different workers trying to use the same tool or change the same piece of information all at once?
Well, that's where you can get into trouble with something called a race condition. Let's just walk through a quick example. Thread A reads a number, say 10. But before it can do anything, thread B swoops in and reads that same number, 10. Now, thread A adds 1 and writes back 11. But wait, thread B still thinks the number is 10, so it also adds 1 and writes back 11. The result should have been 12, but nope, our data is now corrupt.
So how do we stop this from happening? Luckily, Java gives us some powerful tools for synchronization. For instance, locks are basically like a key to a room. Only one thread can have the key and access the resource at a time. Semaphores are more like bouncers at a club. They limit how many threads can get into a specific section of code at once. And then you have atomic variables, which are perfect for simple things like counters, guaranteeing that an entire operation happens as one single, uninterruptible step. Getting these down is crucial for safe concurrent code.
Okay, let's switch gears a bit. We've talked about raw power. Now let's talk about writing code that's clean, elegant, and just beautiful to read. Let's talk about the power of streams. Think for a second about the classic way you'd process a list of something. You write a for loop, you stick an if statement inside, you create a new empty list to hold the results. It's just so much ceremony and boilerplate code for a simple idea, right? The Stream API flips this completely on its head. It turns the whole process into this logical pipeline. You start with your data source, your list. Then you just chain together operations, filter out what you don't want, map what's left into something new, and finally, collect all the results into a new list or a single value. And this is the payoff. All of that bulky, hard-to-read loop logic just melts away into one clean, super readable line of code. It's not just that it's shorter, it's that it describes what you want to do, not the messy details of how to do it. It makes your code so much easier to understand at a glance. All right, next up. Let's look at a couple of modern APIs that were specifically designed to solve some of the most common, frustrating problems developers face, helping us write fundamentally better and safer code. The null point exception, probably the #1 headache for generations of Java developers. The old way to avoid it was to sprinkle your code with if something doesn't equal null checks everywhere. It's ugly, and worse, it's so easy to forget one. The modern solution is to use optional. It's basically a little box that might or might not contain a value. It forces you to think about and handle the empty case, which makes your code's intention way clearer and a whole lot safer.
And that's not the only area where Java's had a major glow-up. Dealing with dates and times used to be an absolute mess with the old java.utilDate class. But ever since Java 8, we've had the Java Time API, and wow, what a difference. It's clear, it's precise, and it's actually fun to work with. It's just another perfect example of how the language is always evolving to fix real-world pain points.
And you know what? Java is not done evolving. There are really exciting things coming down the pipeline, like Project Loom. It's set to completely revolutionize concurrency with this new concept of virtual threads, making it even easier to write massively concurrent applications. It just goes to show, Java is alive and kicking.
Okay, we've covered some seriously powerful concepts. Let's pull it all together now and talk about what this means for you in our final section, your mastery roadmap.
Here's the big takeaway. You now have the keys to unlock that next level of Java development. You get the ideas behind handling concurrency, processing data elegantly with streams, and using modern APIs to write tough, reliable code. This isn't just about writing code anymore. This is the path to becoming a software architect.
Now, obviously, this is just the starting line. To really go deep, I can't recommend the official documentation enough. You should also check out absolute classic books like Java Concurrency in Practice, and of course, get involved in online courses and community forums.
So, we've laid it all out. You've seen the path from where you are now to becoming a truly advanced Java developer. There's really only one question left to ask. Which one of these powerful concepts are you going to master first?